NASA's Voyager 1 spacecraft, which today holds the distinction of being the most distant human-made object, has captivated people around the world for almost 5 decades. Since its dispatch, Voyager 1 has relayed essential information from the farthest boundaries of outer space, deepening humanity's grasp of the cosmos. Yet the probe's recent broadcasts have shown peculiar irregularities that have bewildered experts. These cryptic signals have sparked heated debates, leading the scientific community to ponder whether these anomalies are simply hardware glitches or evidence of something far more remarkable, possibly even extraterrestrial origins. Join us as we examine these baffling messages and probe what might lie hidden in the vastness of space. Our innate human urge to uncover enigmas has long propelled the pursuit of space exploration. This profound curiosity led to towering ventures like Pioneer 10 and Pioneer 11, among the most audacious space endeavors of their time. On August 20, 1977, the deployment of Voyager 2 from NASA's Kennedy Space Center signaled the dawn of a revolutionary epoch in space study. Soon after, on September 5, 1977, Voyager 1 was launched, embarking on a voyage that would bring it to the outer planets, dramatically shifting its course and scientific objectives. Each probe, weighing about 721 kilograms, similar to a small family car, journeyed in unique directions at varying velocities. On December 15, 1977, Voyager 1 achieved a major milestone by overtaking its sibling in terms of distance traveled, owing to their diverging trajectories. Since then, Voyager 1 has served as a vital instrument in expanding our awareness of space, yielding discoveries that have reshaped our comprehension of the universe. Before exploring its more recent groundbreaking outcomes, let's revisit some of its earlier pivotal achievements. In 1979, located approximately 265 million kilometers from Earth, Voyager 1 captured high-resolution imagery of Jupiter. By January of that year, it had conducted an extraordinary 100-hour observation, culminating in a time-lapse sequence that illustrated Jupiter's rotation. This collection of 3,750 photographs delivered unmatched insights into the planet's tumultuous atmosphere and intricate details. During that mission, Voyager 1 also detected a previously undiscovered ring around Jupiter and uncovered 2 unknown moons, significantly enriching our understanding of the gas giant's complex system. To keep on course and avoid a collision with Titan, one of Saturn's moons, the probe executed several navigational tweaks. Thereafter, the mission shifted focus beyond the solar system's planets, redirecting the spacecraft into interstellar space, cruising at an impressive speed of 325 million kilometers per year. In January 1990, Voyager 1 began its mission to survey interstellar space, continuing its journey beyond the limits of our solar system. During this stage, it accomplished several astounding feats, such as identifying 4 additional moons, Mimas, Enceladus, Tethys, and Rhea, and capturing some of the most unforgettable shots of the solar system's outer edges. On February 14, 1990, from about 6 billion kilometers from the Sun, Voyager 1 shot the iconic family portrait, a panoramic set of images of the inner planets. This array of 60 pictures was appended to the probe's extensive collection, which already included hundreds of images from its close approaches to the gas giants. Voyager 2, meanwhile, accomplished remarkable feats during its own journey. It measured wind velocities on Neptune reaching over 2,100 kilometers per hour, around 1,300 meters per second, the fastest atmospheric winds ever recorded in our solar system. It also observed Triton, Neptune's largest moon, where temperatures plunged to a frigid minus 391 degrees Fahrenheit minus 235 degrees Celsius, placing it among the coldest known locales. Triton displayed signs of icy eruptions, spewing nitrogen gas and frozen debris up to 5 kilometers high, exposing captivating new insights into its surface activity. These extraordinary revelations significantly expanded our understanding of the diverse and dynamic conditions in the solar system's outer domains. The contributions of Voyager 1 and Voyager 2 have been genuinely transformative. Their observations revealed previously hidden traits of Jupiter and Saturn's satellites, once believed dormant. This fresh evidence revamped theories about their geological dynamism. Voyager 2 especially etched history by remaining the only spacecraft to date to pass near both Uranus and Neptune, a singular accomplishment. NASA implemented inventive tactics to prolong the lifespans of these groundbreaking missions, such as powering down non-essential systems to conserve energy. The campaign is expected to persist until 2030, heralding the conclusion of an extraordinary chapter for the teams dedicated to this mission. Voyager 1 and Voyager 2's construction exemplified cutting-edge engineering. Designed to rotate gradually, these probes minimized motion blur in their imagery while in transit. Even before arriving at the outer planets, the spacecraft began transmitting intricate visuals of Jupiter, revealing its swirling clouds and the iconic Great Red Spot, a massive storm that has intrigued researchers for decades. A standout discovery was the detection of active volcanoes on Jupiter's moon Io. The instruments aboard the probes recorded unusual readings, later corroborated by images showing colossal volcanic plumes and a reformed surface. One eruption on Io was found to be 1,000 times more powerful than Mount St. Helens, covering an area nearly the size of France. As their odysseys continued, both spacecraft were gradually powered down to conserve fuel before entering interstellar space. Notably, they didn't photograph Mercury or Mars due to technical limitations. NASA later launched other notable missions such as Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Pioneer 10 overtook Pioneer 11 to become the most distant probe from Earth. Yet, Voyager 1 journeyed onward for another 14 years before officially entering interstellar space on August 25, 2012. A key factor in the success of these missions was the clever use of gravitational slingshot maneuvers, which boosted the spacecraft toward their targets while preserving fuel. Rather than relying solely on propulsion engines, they leveraged planetary gravity to increase speed and alter course. This approach enabled them to traverse vast distances using minimal fuel. As Voyager 1 neared Jupiter, the planet's immense gravity accelerated the probe. Accuracy was vital to avoid dangerous deviations in speed or trajectory. These gravity-assisted boosts enabled the probes to adeptly navigate the solar system. Voyager 2 also exploited gravitational pulls from Jupiter and Saturn to propel itself toward Uranus and Neptune, demonstrating the efficacy of this navigation technique. Looking back at these remarkable ventures, the scientific community eagerly awaits further revelations from Voyager 1's anomalous signals. These spacecraft remain operational far beyond the known bounds of our solar system, investigating the enigmas of planets like Jupiter, Saturn, Uranus, and Neptune. Voyager 1's time-lapse films vividly documented 10 eruptions on Jupiter and exposed new satellites as well as a previously unobserved ring encircling the planet. These findings greatly enriched our understanding of the Jovian system. Similarly, Voyager 1 discovered 4 more moons orbiting Saturn, Mimas, Enceladus, Tethys, and Rhea, while delivering stunning visuals of the planet and its rings, revealing their intricate formations. The mission's expeditions to Uranus and Neptune yielded vital observations concerning their atmospheres and moons, bolstering our comprehension of the solar system's remote regions. After completing their planetary flybys, both probes charted a path toward interstellar space, where they continue to send invaluable scientific data. This ongoing inquiry broadens our perspective on what lies beyond our celestial neighborhood. As we anticipate updates regarding Voyager 1's bizarre transmissions and their ramifications for our cosmic understanding, these extraordinary missions continue to inspire scientists and enthusiasts worldwide. Their achievements remain foundational in extending human knowledge and pushing the frontiers of space science. The Voyager programs have provided unprecedented glimpses of our solar system far beyond its bounds, delivering iconic imagery and vital scientific knowledge. Beyond their empirical legacy, the spacecraft carry a symbolic treasure, a message representing Earth to any extraterrestrial civilizations. The Golden Record comprises greetings in 55 languages, musical compositions from diverse cultures, and natural sounds like thunder and whale vocalizations. This interstellar communique stands as humanity's optimistic overture to intelligent life beyond our planet. Voyager 1 and 2 carried a suite of scientific instruments that significantly broadened our understanding of space. These included magnetometers, plasma wave detectors, and imaging sensors, all furnishing essential data about space environments. The magnetometers decoded the magnetic fields of Jupiter, Saturn, Uranus, and Neptune, showing how they interact with their surroundings. Plasma wave instruments clarified the impact of solar winds on planetary atmospheres. A highlight of the mission was charting the border of the heliosphere, a colossal region filled with solar particles and electromagnetic fields enveloping our solar system. As Voyager 1 neared this frontier, it observed a shift from solar wind to interstellar medium, offering vital insights into how this shield guards Earth from cosmic rays. The spacecraft pinpointed a zone known as the termination shock, where solar winds slow and compress. Beyond it lies the heliosheath, a turbulent layer where solar and interstellar particles collide, creating a dynamic environment. Voyager 2's journey also enormously enhanced our understanding of the outer solar system. Its close encounters with the giant planets yielded key observations, particularly regarding Uranus's magnetic field, which was found to be tilted in an unexpected fashion that defied theoretical models. These revelations have spurred additional investigations into planetary magnetism. These missions not only advanced scientific knowledge but also rekindled public enthusiasm for space travel. The spellbinding images of remote planets and the enthralling narratives of these missions have inspired countless individuals across generations. Iconic visuals, such as Saturn's graceful rings and Jupiter's volcanic moons, have become emblematic, motivating future scientists and explorers. As Voyager continues to transmit extraordinary information, its extended venture into interstellar realms offers unparalleled chances to decipher the essence of the universe. Although former focus often fell on our solar system's planets, exploring interstellar space has revealed unexpected intricacies. Regions once thought barren now show elaborate phenomena that defy current scientific paradigms. Among the most enthralling discoveries is the detection of cosmic rays from beyond our solar system. These ultra-energetic particles, traveling almost at light speed, offer clues about processes in remote sectors of our galaxy. By analyzing their energy and composition, scientists aim to better understand the workings of distant stellar nurseries and galactic dynamics. Moreover, as Voyager 1 and 2 venture deeper into interstellar space, their onboard instruments continue to measure the density and movement of the interstellar medium, the sparse matter that fills space between stars. This material, composed of gas and dust, interacts with solar wind and shapes the heliosphere's structure. As the probes journey through it, they relay priceless data that help researchers model how energy and matter behave across cosmic expanses. Additionally, the Voyager missions have revealed essential information about magnetic fields in interstellar space, illuminating their characteristics and influences. These findings could eventually foster breakthroughs in our understanding of galactic magnetism. The ongoing exploration of these remote frontiers not only enriches our scientific insight but also inspires succeeding generations of astrophysicists and engineers. The unforgettable shots captured by Voyager, most notably the famed pale blue, showing Earth from more than 6 billion kilometers away, serve as a sobering reminder of our minuscule place in the cosmos. These images, along with the mission's scientific milestones, have profoundly altered how we view our planet and its position in the universe. The success of the Voyager missions has cleared the path for even more ambitious expeditions. Thanks to the technological advances forged during their missions, deploying sophisticated probes to even more distant corners of our galaxy is increasingly within reach. Aspirations such as exploring exoplanets, identifying potentially habitable worlds, and even interstellar voyages are steadily advancing from visionary ideals to achievable objectives in the future of cosmic exploration.